Hello, geometry students. Welcome back from winter break. I hope that your break was restful and you got to enjoy time with your family and loved ones. I am Miss Holloway. I'm going to be your new geometry teacher for this semester. If you have accessed the Canvas course and done attendance, make sure that you do that first before you take notes, and that way I can make sure that I count you present for the day. Also today is National Whipped Cream Day. So if you have any hot chocolate or ice cream, make sure to put some whipped cream on it to celebrate. Today we're going to be talking about the Pythagorean Theorem. And when we're talking about the Pythagorean Theorem, we're only talking about right triangles. So you can only use Pythagorean Theorem with right triangles. So I want to make sure that we take notice that it's only in right triangles that we use the Pythagorean Theorem. If you have your notes with you, you can follow along with me here. Otherwise, if you don't have your notes, make sure that you get a journal that you're filling out notes as I go along. So here we go. We're going to label our right triangle first. In a right triangle, you always have two legs, right? And your longest side, which is across from the right angle, is called your hypotenuse. And way a long time ago, Pythagoras learned that you can find the lengths of the sides of right triangles if you use a formula. And so Pythagoras came up with this formula: a squared plus b squared equals c squared. You've probably seen this before, where a and b specifically are the legs. So your legs can be A or B, they can be interchanged, either one, but your hypotenuse is always C, right? Hypotenuse is always labeled C. So let's look at this for an example. So these can be interchanged, but this is always your hypotenuse. That's very important. So let's start with an example. Let's find the value of x. We have two known values of our right triangle, and we're looking for the third value. Well, let's first start by labeling, right? We always want to label when we are in geometry, especially when we're working with figures. So I'm going to label using my A, B, and hypotenuse. So my leg for 7, this 7 is going to be A. It could be B if you want it to be B. 3 is going to be B. And x is going to be c. So I'm going to write down my formula, and then solve. These are our reoccurring steps for our geometry. Anytime that you have a figure, you always want to label, then write down your formula, and then solve. So I'm going to write down my formula here. It's a squared plus b squared equals c squared. And then I'm going to plug in my values. A is 7. B is 3, and C is our unknown value. So now we'll solve. 7 squared is 49. If you did the squares and roots practice from the warm-up, you should know these automatically, right? 3 squared is 9, and C squared. 49 plus 9 here is what, 58, right? Equals C squared. And whenever we're solving equations, we always want to do opposite operation, right? So I want to know what the opposite operation of squaring something is. So opposite operation of squaring, so anytime I square something, the opposite of that is taking the square root. So just a little side note there. So I'm going to take the square root of c squared, and I get the square root of 58. Now did it freeze? Sorry about that, I'm not sure what happened. Okay, I had a little freeze moment. So my answer here is going to be the square root of 58. So looking from our practice of reducing these squares, I want to know if I can reduce this or simplify this radical. Well, I do know that this is 2 times 20 right? And both of these are prime numbers, so I know that it can't reduce anymore. So I'm going to say this is my simplified radical. Let's try the second one. The second one is a little bit trickier because it has a radical in it. So what are we going to do first? We're going to label, right? So let's label our triangle A, B, and C. This could also be A and B. This is always going to be C here because it's our hypotenuse. Write down our formula, A squared plus B squared equals C squared, and plug in. So X is your A squared, 6 is your B squared, and 6 square root 2 is C. So I want to make sure that I put these in parentheses because I don't want you to forget that we have to square both our values here. We have to square 6 and the square root of 2. Alright, so let's go ahead and solve. 6 squared is 36, and then here I have to square both values. So 6 squared is 36, and the square root of 2 squared is 2. So I want us to think about that. Square root of 2, if I square that, that means I have the square root of 2 times the square root of 2. That makes the square root of 4. Well, what's the square root of 4? Yes, you're right, it's 2. Good job. Alright, so we have x squared plus 36 equals 36 times 2, which is 72. And I'm just going to go about solving this. So, since I'm adding here, I'm going to get rid of it by subtracting. So I have x squared equals 36. And we're going to do the same thing that we did up here, which is the opposite of squaring. So I'm going to take the square root, right? What's the square root of 36? It's 6. Maybe you'll see this pattern later on, but both of these legs are congruent, if you'll notice that. Very interesting. We'll learn about that next time. Alright, next example. Find the value of x. This one's a little bit trickier because I have this trapezoid looking figure here, but I can turn it into a right triangle by drawing a line here, right? So it's perpendicular, which is, we have to figure out what this is now. If that's 5, then that's 5. This must be 6, right? If this is 8, then this is going to be 8. Let me move my mouse so it doesn't get distracting. Alright, let's label first. Then we'll write our formula and then we'll solve. So label, let's label that A, B, and our x value is C. So we have A squared plus B squared equals C squared. You don't have to write the formula every time, but it will help, I promise, because it helps you to remember what it is. Let's plug in. 6 squared plus 8 squared equals C squared. 6 squared I know is, oh, I wrote that backwards, didn't I? It's okay to mess up, that's why we use pencils. 6 squared, how about is 36? We just did that. And 8 squared is 64 equals C squared. We'll add these together, which gets me 100. And then just like the other two, the opposite operation of squaring something is taking the square root. So that's what we're going to do down here. We're going to take the square root, okay? So C equals 10. I love it when they come out perfect like that. Alright, so you've had our 3 examples. You should feel pretty good wherever your x value might be. We've had it in the hypotenuse and we've had it in the leg. So let's go ahead and flip to the other side and look at Pythagorean triples. Pythagorean triples are just known numbers that make up a right triangle. So some of my known numbers are like 3, 4, 5. I'm going to let you do the rest of this taken from your supporting documents on your notes page. But I want to see, is 3, 4, 5 a Pythagorean triple? I already told you yes, but I'm going to prove it to you using that a squared plus b squared equals c squared. So let's see, let's prove that they're a that it's a right triangle. So I'm going to say 3 squared plus 4 squared equals, not c, how about 5? 5 squared. Okay, how did I know that 5 was the hypotenuse? That's because your hypotenuse is always your longest side, right? Always longest. So I'm going to always put it where C is for the hypotenuse. All right, 3 squared is 9. I'm going to move over here. 4 squared is 16. And 5 squared is 25. 9 plus 16 is 25. So my question is, does 25 equal 25? Yes, it does. And so it is a right triangle because they're equal, okay? So I'm going to let you fill in those other spots because that's part of your discussion on your notes discussion page. So I'm going to let you do that. But I'll give you this hint. Any multiple of these Pythagorean triples are also Pythagorean triples. So if I already know that 3, 4, 5 is a Pythagorean triple, then I also know that 6, 8, 10 is a Pythagorean triple. See what I did there? 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So if I find the next multiple of those numbers, then I know that that's also a Pythagorean triple. Little hint there for you. Okay, more information here. Did you know that we can also use the Pythagorean theorem to prove whether something is a right triangle, an acute triangle, or an obtuse triangle? Well, let's see. A right triangle we know is when you say a squared plus b squared equals c squared. Remember, we proved that with our Pythagorean triple 3, 4, 5. But what about an acute triangle? You can use the same formula, but using an inequality will tell you whether it's an acute triangle or an obtuse triangle. So let's think back to our acute triangles and our obtuse triangles. Acute triangles, and this is how it makes me remember it, right? Acute triangles have longer legs, okay? So this is A, B, and C. Remember, C is always the longest. I know it doesn't look that way, does it? And then obtuse triangles, B, C. So acute has a less than 90 degrees, right? They're all less than 90 degrees. So none of them are 90, they're all less than 90 degrees. For obtuse, you have one of them that is greater than 90 degrees, right? So that's our obtuse and our acute. Acute. Let me label correctly. So we're going to prove whether things are less than, or whether they're obtuse or acute. You can do that using the Pythagorean theorem. So let's look. I'm going to tell you which one is which. When your legs add up to be longer than your hypotenuse, then it's greater than, right? That's acute. That's how I always remember it, like this. When your legs add up to be shorter, or the squares of your legs, let me be really specific there. The squares of your legs add up to be shorter than your hypotenuse or your longest side, then it's going to be obtuse. Okay? That helps me remember by seeing the picture. So let's see if a triangle can be formed by seeing if all of the sides add up to be longer than the third side. And then I want to see what kind of triangle it is. So I'm going to use my whiteboard because there's not a whole lot of room in that space. So my first one is 5, 12, and 4, okay? So you have to do two things. So is it a triangle, right? And then I want to know, is it right, is it obtuse, or is it acute? So we're going to say, is it a triangle, by doing this. The sum of any two sides has to be greater than the third side. So let me show you what that looks like. 5 plus 12 has to be